All right, here we go. Unit 4, Lesson 2. We're going to do second day working with implicit differentiation. The two things we're going to do today are we're going to talk about what second derivatives defined implicitly look like, and then we're going to do an AP-style implicit derivative problem. So this notation here, there's not a typo. This is the notation for the second derivative of a function implicitly. What this means is, this means the second derivative of y with respect to x. So this is the second derivative of y with respect to x. And we're going to see why it looks like there might be a typo there, but there's really not. So remember, the first thing we do with implicit differentiation is we take the derivative with respect to x, which is what that symbol means, of both sides. So we're going to take the derivative of y squared plus 2y, the derivative of y squared plus 2y, and we're going to take the derivative of 2x plus 1. Going through piece by piece, the derivative of y squared with respect to x, remember y is a function of x, so this is a chain rule problem. It's like you have y of x squared, right? So what we need here is 2y, that's the outer function, and then I prefer to write dy dx. You'll see in Delta Math, they use y prime. Means the exact same thing. I just think the notation is a little bit more clear if you use dy dx. It also makes this next part make a little bit more sense. Then plus 2, basically have plus 2 chain rule dy dx. And all of that's going to be equal to the derivative of 2x plus 1, which is just 2. And so now what we have to do here is we have to solve for dy dx. So the move you want to make is to factor it out of both of these. So we have dy dx times 2y plus 2. All of that's going to be equal to 2. And then we're going to have the derivative of y with respect to x is equal to 2 over 2y plus 2. So that's straightforward. That is the first derivative with respect, the first derivative of y with respect to x. Now here is what this question is asking you though. If you were just asked to find the first derivative implicitly, that's it. So what this says is this is some function where the derivative actually only depends on y. It doesn't even depend on x at all. It just depends on y. So if I tell you the y coordinate, you can tell me what the derivative of that function is. But what we're asked to find is the second derivative of that function. We're asked to find the second derivative of that function. And here's why I said it might look like a typo. Like, why do I have the squared on the d in one term and on the x in another? Well, think about what's going to happen here. If we take the second derivative, we are going to be taking the derivative with respect to x. And so the way this gets written is the second derivative of y with respect to x. And it's not really a fraction, but for the purposes of this, you can think of it like it is. And so we have the second derivative of y with respect to x is equal to, now this is going to require the quotient rule. When we go to take the next derivative with respect to x here, this is going to require the quotient rule. So remember, 2 is going to be f in this case, and 2y plus 2 is going to be g. So what we're going to have here is f prime, oh, well, this makes this easy. F prime is 0 times g, so 0 times 2y plus 2, minus f g prime. Now, this is the derivative, again, with respect to x. So the derivative of 2y plus 2, we would normally just say if it was with respect to y, it's 2. But don't forget here, it's 2 dy dx. So I just want to zoom out, make sure we see what's going on here. The derivative with respect to x of 2y plus 2 is 2 dy dx plus 0. So by the chain rule, it's 2 dy dx. All of this over 2y plus 2 squared, all over g squared. Now there's one last thing you'll have to do. when doing these kinds of problems, and that's you have to realize we actually know what the first derivative is. We can substitute this back in. So this is actually equal to, so the 0 times 2y plus 2 will cancel. This is negative 4 times dy dx, which is just 2 over 2y plus 2, right? Because we know that from the previous part of the problem, over 2y plus 2 squared. And so we could probably get like a little bit fancier here. If it was a free response question, again, so this is dy dx here. If it's a free response question, you can stop wherever you want. In this case, though, might as well. We have 2y plus 2. That's going to be on the bottom. So what we're going to finally have here is negative 4 times 2 is negative 8 over 2y plus 2 squared. And, or sorry, cubed. And that's going to be our final answer. You probably get a little fancier and factor out some 2's there, but I'm going to stop there. That's good enough. If I asked you to evaluate the derivative, say I asked you to evaluate the second derivative at a point, which would typically, you'd see it like this. It would be like x equals 1, y equals 4. You would just start to plug in for x and y, and I think that's how the delta math ones are going to look. So that's how a second derivative looks. Let's just quickly go through one example of an AP-style problem with implicit differentiation. So this is from the 2008 exam. I'm going to do these one step at a time. Number one, show that dy dx is negative x plus 1 over 2 times y cubed plus 1. This is great. They're telling us that's the answer. We just need to show it. And so the first point is always going to be here for just trying to do implicit differentiation. So we take the derivative with respect to x of x squared plus 2x plus y to the fourth plus 4y equals the derivative with respect to x of 5. And so we just need to make sure that we get the same thing that they said. Well, the derivative of 5 is 0. The derivative with respect to x here of x squared is 2x, of 2x is plus 2, of y to the fourth is plus 4y cubed, chain rule, dy dx, plus 4, chain rule, dy dx. And so we're just going to solve here. We're going to move everything over to the other side. We're going to have that this is negative 2x minus 2 is equal to dy dx times, I'm skipping, a few steps here, but y'all can handle a little bit of algebra missing. That's fine. Derivative of 4y cubed plus 4. Dividing both sides here, we'd get the derivative of y with respect to x is equal to negative 2x minus 2 over 4y cubed plus 4. We can do a little bit more factoring. We can factor out a negative 2 times x plus 1. Factor out a 4 times y cubed plus 1. And then reduce this to negative 1/2. Or let's just make it exactly like how they've written it there. They keep the negative on top. So we're going to have negative x plus 1 over 2 times y cubed plus 1. So just a little bit of algebra there. The algebra is the trickier part there versus the calculus. Okay. Part B. Write an equation for the line tangent to the curve. I don't even start reading. I see that and I immediately say, okay, point of tangency, slope of the tangent line. Okay. I need a point of this tangent line and I'm given it. I'm just straight up given that the point of tangency is negative 2, 1. Easy. Okay, now the slope of the tangent line. Remember, if we're talking about a normal Cartesian coordinate plane, the slope of the tangent line is the derivative of y with respect to x. They gave it to us. So important note here, even if you couldn't get A, they straight up told you, what dy dx is. So we're just going to be plugging into that. So the slope of the tangent line is going to be negative, x is negative 2, negative 2 plus 1 over 2 times y cubed is 1 plus 1. You work this out a little bit. This is negative 1. So this is positive 1 over 2 times 2 is 4. So our slope of the tangent line is 1/4. So we would have y minus 1 is equal to 1/4 times x minus -2. You can make that x plus 2, or you can just leave it as is. We'll do it just for fun. Y minus 1 is equal to 1/4 times x plus 2. So there's our equation of the tangent line. Question C. Find the coordinates of 2 points on the curve where the line tangent to the curve is vertical. So once again, you don't need to, even if you couldn't get B, right? They're always designed that you can kind of jump back in at any point. If the line tangent to the curve is vertical, right? And so this will be the last one I can kind of squeeze on here. Tangent to the curve is vertical means that the derivative is undefined, right? Means that the derivative is undefined, and the derivative will be undefined when its denominator, when 2 times y cubed plus 1 will be equal to 0, or when y cubed plus 1 is equal to 0, or when y cubed is equal to -1. Taking the cube root of both sides, or just thinking about it in your head, the cube root of -1, the number that times itself 3 times is -1, is -1. Now, they said 2 points. The reason they said 2 points is that these, like I said, if you start implicitly defining functions, there's going to be multiple x values here, although this could be true with a regular function as well, but there's going to be multiple values that could give you a y of -1. So we need to take this y of -1 and we need to plug it back into our original equation. So our original equation, remember, was x squared plus 2x plus y to the 4th plus 4y plus 5. Or sorry, plus 4y equals 5. And so we would just take this and we would plug back in -1 and we'd solve for x. So x squared plus 2x plus -1 to the 4th plus 4 times -1 equals 5. X squared plus 2x. This is going to be a negative number to an even power. That's a +1. Minus 4 is equal to 5. X squared plus 2x minus 3 is equal to 5, right? I hope we haven't forgotten some of our Algebra 2 equation solving techniques here. When you have a trinomial or a highest term of squared here, it's probably one of those ones where you want to bring everything to one side and factor to find solutions. So we subtract 5 from both sides. We get x squared plus 2x minus 8 is equal to 0. And the reason we do this is because we can look at this and we can say this factors as x plus 4 times x minus 2. And now we can see that x equals -4 or y equals +2. So our answers here, right, those are the x values that would make y equal -1. So our answers here are -4, -1, and, sorry, I wrote there a y, that should be an x, and 2, -1. Those are going to be the two locations. There's a part D here, but we're at 14 minutes, and that's enough to get you started for today. So we'll go over that part D at another time. But this is a good place of any to wrap up. Just again, key points here to remember is that when you are taking the derivative with respect to a different variable, the chain rule says you want to tack on a dy dx or a dt dx or whatever the other variable may be. Otherwise, it's just some normal point of the tangent line, slope of the tangent line stuff. All of those same rules apply. The most important sentence in calculus continues to be that the derivative is the slope of the tangent line.